All right, so we're going to be talking about 3-4 graphing rational functions today. There is a 5-step process to graphing rational functions. Step 1 is always to find your horizontal asymptote. This describes your end behavior. It doesn't describe necessarily that your graph will never cross the asymptote, as I stated earlier. What it does state is that as your graph approaches infinity in the x direction, your y value is going to approach whatever this horizontal asymptote is, if it exists. There are 3 rules in order to find your horizontal asymptote, and there's 3 cases for those 3 rules. The first case is if the degree is bigger in the denominator. You don't really need to do any math there. The horizontal asymptote will always be at y equals 0 in that case. If it's the same degree, you take the ratio of the leading coefficients. So if you look here, we've got a 2 as the exponent on the top and a 2 as the exponent on the bottom. That simply means that the exponents are the same, and we can use the ratio of the leading coefficients to figure out our horizontal asymptote. The leading coefficient is the number in front of the x of your largest term. So here we have a 1 on the top in the numerator and a 2 in the denominator, which means that if we are using a ratio of this to find our horizontal asymptote, we're going to have y is equal to 1 over 2. The third case is where you have a larger degree in the numerator, and if you see, we have a 3 here and a 2 here. So when that occurs, this is similar to the first case, except that you have no horizontal asymptote. This will always be true as well. All right. Step 2, you're going to be factoring and simplifying. We've been talking about factoring now for 3 units. At this point, you should be able to recognize when to factor and how to factor. Step 3, you're going to find your zeros of the remaining factors. So what that means is you're going to set either the numerator or the denominator equal to 0. If you set the numerator equal to 0, you're solving for your x-intercepts. If you set your denominator equal to 0, you're solving for your discontinuities. And we need to remember that there are 2 different types of discontinuities. Those 2 different types are removable discontinuities, which are going to be your holes, and you have non-removable discontinuities, which are going to be your vertical asymptotes. Step 4, this is new for this lesson, and I'll explain how to do it whenever we're going over an example, but you're going to create a sign chart. In step 5, you're going to take all this information that you have figured out so far, and you're going to graph it all. All right.